Welcome! Throughout this video, we will show you how we re-engineered the ancient axe. Due to their ability to be put to hard use without chipping or breaking, bronze tools like the axe were an enormous improvement over their stone counterparts for those who could afford them. Due to the limited availability of copper and tin during the early Bronze Ages, these tools were used mostly by the elite. But because they could be reworked and resharpened with ease, these tools could serve well for many years. Over the years, the axe heads grew larger and larger due to the greater availability of copper and bronze. We first start by designing the axe head using 3D modeling software. A 3D printer is used to create a positive for the mold. The positive can be made out of many different materials other than plastic, such as wood or clay. We chose to use a 3D printer due to lack of artistic abilities and to keep dimensional accuracy. Our mold was made out of plaster of Paris. The first step is mix the plaster of Paris with water until the substance becomes milky. The 3D printed model is then covered in modeling clay to act as a release agent. A corkscrew is added to help remove the positive from the cast once it is dry.
I don't know if it's even working. I don't think it is. Oh, there we go.
Once the plaster of Paris has reached the right consistency, it is poured into a container. The positive is then submerged into the plaster of Paris. Our first attempt was unsuccessful. For our second attempt, we added soap to help as a release agent on the side of the container and the positive. Repeating previous steps, the container was filled and the positive submerged in the plaster of Paris. After the mold was mostly dry, the positive was removed and the cast was placed in the oven to remove the remaining moisture. We were very successful in our second attempt at creating a mold. The copper bars were placed in a crucible. An induction furnace was used to melt the copper. Safety was our number one priority. While the copper was being heated, we performed a practice pour with a room temperature crucible. While the aluminum was being heated, we preheated our mold to 400 degrees Fahrenheit. The induction furnace was turned off so that we could check the temperature of the molten aluminum. We measured a temperature of around 1400 degrees Fahrenheit, which is a good pouring temperature for aluminum. Safety was our utmost concern during the pouring of the aluminum. Boots, pants, a jacket, gloves, and a full helmet should always be used during the pouring of molten metal. The mold was filled until the aluminum was just below the top of the mold. The excess aluminum was poured out so it can be reused. After the casting cooled for 4 hours, a hammer was used to break open the cast and remove all of the plaster of Paris. Although the axe was not made of copper, the casting worked very well. Special thanks to John and Bill at the ISC Manufacturing Lab for allowing and helping us to use the induction furnace. Thank you for watching, and we hope you enjoyed our re-engineering of the ancient axe.